Exercise 4.6 from the Calculus with Analytic Geometry written by S.M. Yusuf. Question number 1 till question number 4, integrate with respect to x. Starting from question number 1, sine 5x. Integration of sine raised to power 5x dx. We can write it like integration sine 4x into sine of x dx. We can separate it like this. And we can also write it like integration sine square of x whole square into sine of x dx. And using the identity sine square of x plus cos square of x is equals to 1, we can get the value of sine square of x out of it, and that will be 1 minus cos square of x, this one whole square into sine of x dx. Now I am using here some substitution. Let cos of x is equals to t. So this will be minus sine of x dx is equals to dt, and that will be equals to sine of x dx is equals to minus dt. Using this substitution here, we will get integration 1 minus cos square of x will be 1 minus t square and this whole square, and sine of x dx is negative dt. I am writing negative sign outside and dt here. Now open this square, will get negative. This is 1 plus t raised to power 4 minus 2t square into dt. Now simply integrate it, we will get negative t minus t raised to power 5 over 5 minus minus plus 2t cube over 3 plus constant of integration. Now our t was cos of x, so replace this t with the cos function. We will get minus cos of x plus 2 over 3 cos cube of x minus 1 over 5 cos 5 of x plus constant of integration. So this is the answer for question number 1. Let's move on to question number 2, that is cos 7x. The same method we will follow here, that is integration of cos 7x dx, that is equals to cos 6x into cos of x dx. Now it can be broken as cos square of x whole cube into cos of x dx. Now it can be written as 1 minus sine square of x whole cube into cos of x dx. Now let some substitution here. Let sine of x is equals to t. Let sine of x is equals to t. So this will be cos of x dx is equals to dt. Now replace the terms here in the back step. We will get here integration of 1 minus t square whole cube and cos of x dx is dt. Now this is a cube formula. We know that cube a minus b whole cube. This is equals to a cube minus b cube minus 3ab into a minus b. That is equals to a cube minus b cube minus 3a square b plus 3ab square. Using the same formula here, we will get in our answer 1 minus 3t square plus 3t4 minus t6 and dt. Now we can easily integrate it. The answer will be t minus 3t cube over 3 plus 3t5 over 5 minus t7 over 7 plus constant of integration. This 3 and this 3 can be cancelled out. We get t minus t cube plus 3 over 5 t5 minus 1 over 7 t7 plus constant of integration. Now what was our t? Our t was sine of x. So we will get here sine of x minus sine cube of x plus 3 over 5 sine 5 of x minus 1 over 7 sine 7 of x plus constant of integration here. So this is the answer for your question number 2. Let's move on to question number 3. Question number 3 we have sine 8 of x. This is the more higher power as the previous question, so we can use here the reduction formula. And you know that what reduction formula is. If we have sine nx dx, this will be always equals to minus cos of x sine of n minus 1 of x over n plus n minus 1 over n integration sine of n minus 2 x dx. This is the reduction formula for sine n of x. You have to memorize this formula. Now using this reduction formula here, we will get integration sine 8x dx. This will be equals to minus cos of x sine 7x over 8 plus n minus 1. N here is 8. N here is 8. So we will get here 7 over 8 integration sine 6x dx. We can write it like this. Now it will be minus cos of x sine 7x over 8 plus 7 over 8 and this bracket. Again use the same reduction formula here using n is equals to 6 here. Put the n is equals to 6 here. We will get minus cos of x sine 5 of x over 6 plus 5 over 6 integration sine 4 of x dx and this bracket close. Now open this bracket, we'll get here minus cos of x sine 7x over 8 and this thing will give us minus 7 over 48 cos of x sine 5 of x then plus 35 over 48 integration sine 4 of x dx here. Again using the same reduction formula here. For this, again use the same reduction formula. We'll get minus cos of x sine 7x over 8 minus 7 over 48 cos of x sine 5 of x plus, I'm writing the step here, plus 35 over 48 and this main bracket. And I'm using n here as 4. Replace n with 4 here. We will get here in our answer minus cos of x sine cube of x over 4 plus 3 over 4 integration sine square of x dx. Now it will be, now open this bracket, we'll get minus cos of x sine 7x over 8 minus 7 over 48 cos of x sine 5x. Now multiply this 35 over 48 inside, we'll get here minus 35 over 192 cos of x sine 5 of x and multiply it inside here. This is cube of x. Multiply here inside, we'll get here plus 35 over 64. Integration of sine square of x dx. Now this sine square of x, you know that we can replace it with 1 minus cos 2x divided by 2. We know that sine square of x is equals to 1 minus cos 2x divided by 2. Replace it with this value, move this 2 outside, multiply it with 64. So we will get here minus cos of x sine 7x over 8 minus 7 over 48 cos of x sine 5x minus 35 over 192 cos of x sine cube of x, and this 1 by 2 multiply with outside, we'll get here plus 35 over 128, and inside the integration we have 1 minus cos 2x dx. So we will be left with the same terms I am writing as it is. Now this term, now we have to integrate it. We'll get here plus 35 over 128, and inside we will be left with, we know that what is the integration of this 1 dx, that is x. The integration is x minus here the integration of cos 2x. Integration of cos 2x, we will get here what in our answer? Sine 2x over 2. And we know that sine 2x can be replaced with 2 sine of x cos of x. So this 2 and this 2 can be cancelled out. We will get here minus cos of x sine raised to power 7x over 8 minus 7 over 48 cos of x sine 5x minus 35 over 192 cos of x sine cube of x. Multiply this inside, we'll get here plus 35x over 128 minus 35 over 128 sine of x cos of x plus constant of integration. So this is the answer for our question number 3. Question number 4 is cos raised to power 6x. Using again the reduction formula here, and what is the reduction formula? For cos n of x dx, its reduction formula is sine of x cos of n minus 1 over n plus n minus 1 over n integration cos n minus 2 dx. If you observe that both the reduction formulas are same, but with this sign. We have for the sine nx, we have here negative sign, but for cos nx, we have here positive sign. For the sine nx, the power is on sine function, but for cos nx, the power is on cos function. So this is the one difference that we have in both the reduction formula. So just memorize the one and memorize the hints so that you can just directly write the two reduction formulas out of just memorizing the one. Using this reduction formula for finding this integration, we'll get here cos 6x dx. Now n here is 6. So replace your n with 6. We will get in our answer sine of x cos 5x over 6 plus 5 over 6 integration of cos 4x dx. Now again using the reduction formula here, we'll get again using the reduction formula here, but here n is equals to 4. We will get sine of x cos cube x over 4 plus 3 over 4 integration of cos square of x dx. Now open this bracket, we'll get this 3 and this 2 will be cancelled, get here on 5 over 8. And inside, cos square of x can be replaced with 1 plus cos 2x over 2 dx. So it will become move this 2 outside, we'll get here 5 over 16. And inside the integration will be x plus sine 2x over 2 here plus constant of integration. So now this sine 2x, we know that it is equals to 2 sine of x and cos of x. 2 and that 2 will be cancelled out, and then open the bracket. We will get here now this 2 and this 2 can be cancelled out. So the answer will be left with sine of x cos 5 of x over 6 plus 5 over 24 sine of x cos cube of x plus 5 over 16x plus here we will get 5 over 16 sine of x cos of x plus constant of integration.